Welcome back to Redefining AI, the tech podcast. On behalf of Squirro, the enterprise Gen AI platform, I'm your host, Lauren Hawker Zaffer. Now, today on Redefining AI, we're thrilled to welcome Matthew Theurer, a seasoned global technology executive and entrepreneur with over 30 years of success, leveraging advanced science and technology to solve complex business problems. And Matthew is a co-founder and CEO of Hyperspectral AI, but his career journey has seen him pioneering bold ventures from his early days at NIH to leading successful tech companies, including the sale of Virtualization to AMC for $1.2 billion. Now, with a deep curiosity for the how and why of the world and a knack for identifying technologies that will really alter the world in which they're applied, Matthew is at the cutting edge of applied AI, pushing the boundaries of what is possible across various sectors, including food safety, human health, and defence. So it's a great honour to have him on the show for this conversation. We'd like to welcome in Matthew. Welcome.
Thank you so much, Lauren. I really appreciate the chance to speak with you.
How are you today? We spoke about the time difference, so obviously I'm veering towards the end of my day, but you're just starting your day.
It's great. I love Fridays, obviously, end of the week. Yeah, looking forward to the weekend, but it's a beautiful sunny day here in Maryland, just north of Washington, D.C. So I've got a busy day ahead of me, but I'm looking forward to it.
Have you always resided there?
No, actually. I moved a lot as a child. I was actually born outside of Philadelphia, and then we bounced back and forth between Colorado and Maryland. I was growing up, first my father getting his doctorate, and then he worked for the U.S. government, and we moved back and forth. Spent a large part of my formative years in northern Colorado, but I have lived in Maryland since the late 1980s.
Do you think that where you've lived has impacted where you are just now?
Oh, absolutely. Absolutely. There's some real cultural differences between northern Colorado and the Washington, D.C. area. I'll kind of leave it at that. They're very wildly different. And that's had a big impact on me. I've also, growing up, we drove around the country a lot. By the time I was in 16, I've been in 45 different states.
Hmm.
And I learned a lot traveling the country. And I finally hit the last 50. And I think I made it to the 50th state about 7 years ago, but it's been good.
So one thing that's also probably been just as an adventure is you have over 30 years of experience in technology and you've witnessed countless shifts. If you're to maybe look back from the perspective of the shifts that have happened, is there maybe a historical moment of technological adoption or anything that you've gone through in retrospect where you would say, well, actually, I think that that's posed as a valuable lesson for how we should approach the current AI revolution?
Sure. The first, which is probably mostly forgotten by folks younger than myself, is actually the advent of the PC and really the move away from mainframe computing with the advent of a lot of the Microsoft operating systems on the PC, right? It's completely upended businesses, upended the way people worked. That was, and networking them, of course. And then kind of oddly enough, the advent of virtualization on the x86 platform, which in a lot of ways kind of moved us back to centralized computing. And now we're starting to run multiple operating systems and applications on the same piece of hardware, much like the mainframe. And then, of course, cloud computing, right? Which again, based on virtualization, but just completely had a massive upheaval on businesses, the way people work. You could remotely because all the compute resources were sitting in the cloud. And this had a lot of knock-on effects, especially cloud computing and the power-hungry data centers and kind of knock-on effects of the impact to the need for power generation and lines. And it's very interesting what technological impacts have then on other aspects of businesses and how it affects people, how they work, people's career paths. It's really fascinating to look at the impact of technology beyond the direct impacts of technology.
So, in both of those examples that you've given in terms of the advent of the PC and also highlighting cloud computing and that transition there, you've mentioned the sort of phrases around upending businesses and the way that people work. So do you think that where we are in the position that we find ourselves in with the current AI revolution, that's again to, let's say, classifications or what could be classified, that's what will be impacted most? I mean, it's very sort of high level, but do you feel that that's the two things?
Without a doubt.
Yeah.
Without a doubt. I mean, if you look at businesses, and my own business included, where we leverage AI tools, not only do we create and make an AI-based product, but we use AI to do general business operations, right? I mean, we can do research and create documents that prior to this may have taken, weeks of research and armies of people to do. We don't have to do that anymore, right? I mean, it's go do, interact with an LLM and refine your queries and your statement, and out comes fantastic research, right? And it has a real impact on businesses, on their bottom lines. The most successful businesses are going to leverage AI to reduce their cost, be more efficient. It has an impact on employment. Quite honestly, just saw a post on LinkedIn how they're saying the entry level jobs are greatly impacted with the advent of AI.
That is definitely a conversation. I mean, we could go down that route, but I'm not going to go down that route because there's something far more interesting that you offer in bringing to this conversation as well. So, something that had an impact on us in the whole of the world was COVID-19. And you've
Yes.
publicly spoken as well about the inefficiencies in COVID-19 testing in particular. And this was one of, I think, your catalysts for founding Hyperspectral. Now, what was it about that moment and that particular problem that made you say, oh, wait a minute, there's a better way? And physics plus
Sure.
AI can get us there.
Sure. It absolutely was the catalyst for this company. And I'm sure everybody who's listening to this can remember waiting in line for hours to get swabbed and then having to wait days to get a result back. And completely and utterly necessary from addressing the impact of the pandemic and helping the world deal with it. But it was not sufficient, in my opinion, to address what was happening from a social and economic impact because it did not allow us to go back into the office. It did not allow our kids to get back into school. It was too slow. It took too long. It was too complex when you need to have highly trained lab personnel to run those tests. And we looked at this and said, is there a way to do this, right? Can we combine physics, primarily spectroscopy, with artificial intelligence and do it at the edge, at the point of care, to see if we can detect the presence of these pathogens direct from a sample? And the answer is yes. Now, it's a tough tech problem, but the answer is yes. And then when we looked around, we realized that the standard for testing for contaminants, whether you're talking about bacteria, viruses, or anything else, they use the microbiological processes. When you look at food safety, somebody, a food processor testing their line will do a swabathon and they'll send it off to a lab and they have to grow the bacteria and then they have to test for it to identify it. And you're talking about days quite often before they get an answer back. In the meantime, the food processors, they do it product piling up. Can they ship it? Yes, no, maybe. And they have to wait. And there's a real economic impact. And I've spoken to doctors who are like, it can take days for them to actually definitively know what bacteria is in a wound so that they can treat it. So in the meantime, they prescribe very powerful, very expensive broad spectrum antibiotics, which leads to the growth of antimicrobial resistance, right? So there's this need for very rapid detection of pathogens so that we can not only reduce costs and increase efficiency and stop losing food to spoilage in human health. It's let's get the right antibiotic into the situation right away. Give the doctors and the patients the information they need to address the problems right away. And that's what we focused on doing with our technology is combining artificial intelligence with the data. The idea of using spectroscopy for this is not new. You can find papers going back decades, if not 100 plus years, but it hasn't been really possible in the field at the edge in a rapid, efficient manner now without the advent of AI.
Okay.
AI
Yep.
is necessary to analyze the data.
So it's because, again, when we're talking about seeing the unseen, but how are we talking about seeing the unseen? So when people hear the term, like the term spectropathy,
Spectroscopy.
yes. And the combination with AI. And then there's also another term that you've mentioned before, this hyperspectral imaging. You know, there's probably the immediate connotation of this is something that sounds like sci-fi tech. So how would you break it down and then help us understand, especially the audience, how is AI being used then? We spoke about, is it computer vision? Is it, is prediction, but what does it involve and what are you actually capturing and how does AI step in to interpret the invisible spectrum per se?
Sure. So let's start off with human eye, right? The human eye sees a very narrow range of the electromagnetic spectrum. And by the way, from now on, I'm going to use the term light instead of electromagnetic spectrum, right? But we see a very, very narrow range. Other animals see different ranges. It tends to overlap with the human eye, but they see different ranges as well. Like hummingbirds can actually start to see down in ultraviolet. A lot of animals that hunt at night can see up into the infrared. And there's a lot of information stored there. Now, the human brain has not evolved to, one, be able to interpret that data, let alone the fact that we can't really see it. But we can with sensors, right? We can look from ultraviolet way out into the infrared. And, I look like I look because I interact with light a particular way. You look the way you look because you interact with light a particular way. Leaves are green because of chlorophyll. When we expose or use these sensors to gather the data, so we'll gather data from 300 nanometers in wavelength out to say 25,000 nanometers. Everything interacts and they have signatures. They have a response to it. And there's a lot of different types of spectroscopy. There's absorbance and reflectance. There's hyperspectral imaging, which is actually a combination of photography with spectral wavelengths. So if you think of a standard camera, you have an XY coordinate for a pixel, and then you'll get a red, green, and blue value, right? Well, hyperspectral imager actually measures the actual wavelength. So instead of just red, green, and blue, you'll have maybe 600 readings for every wavelength within it. So you get a lot more granular, fine detail. And this allows us to locate these particles of interest, in this case, like bacteria. Now we have to do it at a fairly high resolution because you're talking about things that are a micron in size. And then what we can do is illuminate them with a laser, which causes the molecules within the shell of the bacteria to vibrate and emit photons. And we capture that emission, and that emission is those emissions result in patterns across this range of wavelengths, which are unique to the bacteria. So we can basically find it using computer vision, illuminate it with a laser, capture the shift. It's called Raman spectroscopy. You feed all that into models, and we can actually say, okay, that's a Listeria bacteria. That's a Staph aureus bacteria. In fact, we can actually even tell the difference between antibiotic resistant and antibiotic susceptible versions of the bacteria, right? But the only way to do that is gather a lot of data, and kind of standard spectrographic techniques of just looking for particular peaks isn't sufficient. You need to have AI, which can look for all of the complex relationships between the wavelengths to properly identify.
So it's not per se around anomaly and trend detection. It's much more advanced to that extent.
It's yeah, oh yeah, it's very specific. Again, we can tell strains, substrains, antibiotic resistance, all of those kind of things within it from the bacteria perspective. Same thing from a viral perspective. And then the whole concept of analyzing spectral inputs, multiple types of spectral inputs. Again, there's multiple types of spectroscopy, allows you to solve other problems.
So that would actually be my next question. So it's almost like you're going from taking a step, to lettuce or E. coli detection to possibly like life-saving diagnostics. Do you see a use case where the technology would be able to dramatically adapt to different environments? And how do you see AI in that particular development tailoring detection for each use case? Because the one that you're highlighting, you've explored it quite deeply, but do you feel that there's the edge of the cusp where you've identified others that dramatically differ from the ones that we've spoken about?
Yes. So the concept of using this applies across many industries, right? So we've done work where we can identify, has a silicon chip been altered from its base, right? So we can basically say, hey, if this is the known version of this chip, and then we can look at, we can say, okay, it's been altered, and here's what's been altered. Hey, there's new circuitry installed. There's the lithography process used to deposit it. It has changed, right? You can tell all sorts of differences. And if you think about, removing the concept of just purely, looking for bacteria or looking for changes in manufacturing processes, what we're really talking about doing is allowing artificial intelligence access to raw, basic sensory input.
Mm.
Okay. So all intelligent life on this planet evolved with multiple senses, right? Vision is one of them, right? And we as human beings evolved to see what we see and react to what we react because it was an evolutionary advantage. We can allow AI to see, if you will, a very broad range of wavelengths to solve all sorts of problems that vision can be solved. So it can quote unquote see things, right? That we can't. You can actually extend this out into the other senses, right? We didn't evolve purely on sight. We have hearing, we have scent, we have taste, we have touch. So you could allow AI access to these sensory inputs at ranges and sensitivities that exceed human beings and allow AI to truly understand the world at a level that it can't today. And you're talking about letting AI get access to raw data as opposed to filtered textual data, right? Which is what all the LLMs are based on. It's already gone through a human process.
Yes, and that you took the words right out of my that's crazy. So that's exactly what I was going. So most AI systems today process filtered data. So it's like
Correct.
written text or structured images, and what you're exploring is what happens when you give AI access to like raw, unfiltered sensory input. And
Correct.
the question is, what does that unlock? Because then you're taking a step closer to a world where machines are essentially smelling, they're seeing, they're touching like we do, or as you've highlighted, even better. So you're claiming here today on the podcast that we're close to that and that we can do that and that we will be able to do it, that we will be able to do it.
I am saying that we will be able to do that. We right now are focusing on the visual, if you will, input. There are companies out there I know that have worked on scent inputs
Mm.
and stuff like that. But yeah, that it's coming, right? And I think the ultimate way to, if you want to get to artificial general
Yeah.
intelligence, you need to allow AI to experience all the sensory inputs.
Yeah.
And it unlocks that incredible amount of capabilities of, it's like, for instance, it's well documented that animals can smell disease, right? They can identify a sick person, right? So they may not be specific as to what the disease is, but they can find it, right? Same kind of thing here. Think of search and rescue. What if search and rescue robots could smell as well as see and hear in ranges beyond the human being, right? So humans hear 20 hertz to, I believe, 20 kilohertz, something like that. But I know that there's auditory sensors which go from the millions of hertz to the 5 terahertz range, right? What if you allowed them to hear? So think of what you could do from a search and rescue perspective if search and rescue robots had all of these sensory inputs and could process it and go find a victim of a building collapse or something like that. That's just one use case that came to top of mind.
That's fascinating. At the moment, this particular field is quite an expensive one, though, isn't it? Because there's a reliance on a lot of, or maybe there's not hardware.
There is. It's luckily, I can speak very in detail around the spectrography world, right? So spectroscopy machines, even 5 to 10 years ago, could have been for really complex high-end ones, you were into the millions of dollars. You're now getting them in the low five figures, and they're actually dropping into the mid four figures for high resolution machinery. And I've spoken to companies that, from a hyperspectral imaging perspective, they have it down to the size of a cost factor that could fit into your phone, right? So that camera on the back of your phone could be replaced with a hyperspectral sensor. You still get pictures, right? You get the same pictures out of it, right? Except there's now, for every pixel, instead of three values representing the color, there might be 600 or 800. So cost is coming down, right, of the data acquisition. The cost to train and build the models is, it's following the same curve as you've seen for the LLMs, right? Well, it took months and or years and millions of dollars is now getting done in hours for a fraction of the cost, right? So the cost is really coming down. And when you get that sensor input into the hand of the consumer, so think of this scenario where you wake up in the morning, you're not feeling well, or your significant other isn't feeling well, or your children aren't feeling well, and you can scan them, right? Take a swab of their nose or literally scan their nose and their mouth and say, oh, you've got strep throat. Goes to the doctor, validates it, and says, okay, all right, here's your prescription, go to CVS, right? And that's all done before you have to leave for work in the morning.
Yeah.
You can do it at home. Or you can check out that somewhat suspects left takeout food you have in the fridge from 3 days ago to see if it's still okay to eat.
Fascinating. So there's one question that I want to end on. AI ethics, they often concern themselves, well, they center around the whole component of social data. And I don't think, and I'm not an expert on certainly scientific data, but I wouldn't imagine that was immune to biases. How do you ensure still fairness, accuracy in?
That's a really good question, right? So, in a lot of ways, since this data is not coming from, have already been filtered by a human being, right? It's not the written word, it's not a pre-known image. So a lot of those kind of inherent, almost unknown biases tend to disappear, right? I mean, the spectral response is the spectral response is the spectral response of something to light. I think where we have to be very cautious and thoughtful about is when and where do we apply this technology to solve the problems, to make sure we're trying to solve issues that have a great deal of public impact for the good to the broadest range of people, right? Unfortunately, one of the things if the AI in general will unlock, not just ours, I think, is the ability to address public health concerns, public health issues that previously had been left off the table because, quite frankly, market pressure makes it not viable to do it economically. I think AI can go a long way towards making it economically viable to start looking for solutions for problems for people who have been, quite frankly, ignored because the bottom line wasn't there.
Yeah. It's certainly, we're at the stage of an interest and development in times of discovery as well. And I think that what you've shared with us today, I'm sure that the audience, a lot of them probably will have heard it for the first time. So it's been absolutely wonderful having you here with us on the show on Redefining AI. And I thank you for your contribution. And I'm sure that everyone else that's joined us has enjoyed the conversation. Thank you for being part of it and for listening.
Thank you very much. I truly appreciate the chance to speak with you and to speak with your audience. And if anybody wants to find me, I'm on LinkedIn, I'm on Twitter. That's pretty much it at the moment.
So catch Matthew there. Thanks again, Matthew. Thank you.
Thank you so much. You take care.